Okay. So factoring is a real important skill in algebra, and previously we've looked at factoring individual numbers or finding the greatest common factor, find the prime factorization. We can also factor polynomials, and the first and the most basic way of factoring polynomials is going to be by factoring out the greatest common factor of those polynomials. So I'm just gonna jump right into an example here, take a look at the problem, and then and go from there and thinking about this concept. So let's say I have a number, a polynomial. Let's do 4. So 4x squared minus 10x. Yeah, all right, I'll leave it at that. Okay, so 4x squared minus 10x. This is a binomial, and it's of degree 2, right? So the highest exponent is of a 2, so it's a degree 2, which also means it's a quadratic. So it's a quadratic binomial. There's some terms associated with this polynomial. Now, it can be helpful to factor it, and this is useful when you get into graphing and into finding the roots of the polynomial, different aspects of quadratics. Factoring can be useful. So let's take a look at factoring this, and we're just going to factor it by finding the greatest common factor. So looking between these two, we need to find out what do these two terms share. So it's not just the number part, but also the variable part, what they share. And so we're going to break each of these terms down into its component parts. So we can take 4 and say, well, that actually factors down to 2 times 2, and x squared is x times x. X times x is x squared. All right, minus, and sometimes it's useful to actually say this is plus a -1, and as -1 being a factor of this term, but for now I'm just going to put minus. And this is going to be 5 times 2 gives us 10. Then x, well, this just means I'm multiplying my variable to 10, so times x. Okay, now we can find what they share, because that's all we're doing here is factoring this polynomial by finding the greatest common factor. So let's see, they both share a 2. They don't have a 5, but they also have 1x in common. Okay, so we know now what the greatest common factor between these two terms is, and that's going to be 2 and an x, or 2x. Okay, that's the greatest common factor. Now, when I factor this, factoring is unmultiplying, or breaking a number or a term down into its components, which would multiply back to the original. Just like this is that for this one monomial, this is a factored form of this term. Well, I can actually break this thing down into what multiplies together to give me this binomial. Okay, in order to have a binomial, well, I'm going to have this 2x, which is greatest common factor, being multiplied, or parentheses mean multiplication, by another, by a binomial here. And we can actually see what that binomial is right here. Notice this 2x is not in common. That means that I'm going to put this here inside the parentheses, because when I multiply 2x times 2x, 2x times 2x, I will get back to my original term. And then minus 5, and that's it. Minus 5 is the only thing left in this term that wasn't a common factor, which that common factor is right here. And close my parentheses. And this is it. And it's good to know that this is now fully factorized. And oftentimes, factoring these polynomials, this is as good as done. Also, if we have other polynomials, maybe we can do some other factoring techniques. It's oftentimes helpful to factor out the greatest common factor first, and then deal with this this inner polynomial, because then our work will be a little easier. So there's some benefits to doing this. Okay. Note too, I said that earlier that factoring was unmultiplying or breaking apart that multiplication, well, look, you can always multiply the factors to get back to the original. And this is kind of just some check work to make sure we factored it correctly. Well, 2x, or this monomial times this binomial, right? We can multiply 2x times 2x, which is 2 times 2 is 4, x times x is x squared, and 2x times -5 is negative, 5 times 2 is 10, and then the x. And lo and behold, it checks out. They're the same, and so I know that that's done correctly. All right. I'm going to do one more quick example here with this one, just to show you just another one. Factoring polynomial by factoring out its greatest common factor. That's what we're doing here. So let's try this. Let's do 18 xy to the third plus, actually let's go negative 18. All right, yeah. Let's put that negative out front. All right, plus, we'll do 15 x squared y squared and plus 3x. Okay, I'm happy with this. It's trinomial. Notice we got three distinct terms here. So 1 term, 2 terms, 3 terms. Okay. Now, when we have a leading coefficient that's negative, it's usually beneficial to then factor that out as a -1. So let's take a look at that. I'm going to break them. We're going to break these apart into their prime factors, or to their factors where they'll be able to immediately see what the greatest common factor is. So I'm going to say that that's a -1, right, times 3 times 3 times 2. That makes -18 times x times, I'm going to say this y to the third. Now I could write y times y times y. But looking here, y to the third, there's a y to the square here, but there's no y in this third term, so I know it's not common to each of those three. So I'm just going to put that as a y to the third. All right. Just kind of looking ahead, making my life a little bit easier for myself. All right. Plus, okay, 15. 3 times 5 times x times x times y squared plus 3 times x. Okay, now let's see, what do they have in common? Okay, well, they have I'll use blue here. They got a 3 in common, and they all have an x. Okay, and I'm actually going to leave that -1. I want that to be one of the factors. I want that -1 to be pulled out as a common factor, because I don't want the leading coefficient to be negative. And so what I'm going to do is I'm going to say, well, a positive is the same as a negative times a negative, right? So I'm going to actually say, this is a little bit of math trickery, you could say. I'm just going to call this negative, or minus a -1, because minus -1 means same as plus, right? Minus -1. Okay, a little bit of that math trickery in there. But now notice the cool thing that did is that gave us a -1 as a common factor. Okay, so now when I find its prime, or its greatest common factor, well, it's -1 times 3, which is -3, and they have an x. So -3x is the greatest common factor. Now, this trinomial is just going to have everything that wasn't part of that greatest common factor. So 3 times 2 is 6, and y to the third. And then minus. So notice I changed that sign so I could factor out the negative number. Minus 5, there's an x, and a y squared. So one way I can think about this, if this is my greatest common factor, these are the things which are left over. Okay, now this last one, minus, well, what's left? I have the -1, the 3, the x, everything's taken, so it's going to be a 1 there, because you can always have a factor of 1. 1 is a factor of everything. Okay, and notice here, if I multiply, so notice these are all those leftover bits. If I multiply these together, I should get back to that original. So we can try that. -3 times 6 is -18. X doesn't multiply to y, or, apples and oranges, so it's just x, y to the third. All right, negative times a negative is a positive. 3 times 5 is 15. X times x is x squared, and then y squared. And again, negative times a negative is a positive, and 3x times 1 is 3x. Okay, and this does it. Checks out. This and this are the exact same polynomial. And so I know now that right here, I have factored out, or I've factored out the greatest common factor, and this is the factored form of this polynomial. Okay, hope that helps. Goodbye.